So we got the basic definition. Let me introduce one more. This is a block. I'll give velocity u. I'll apply a force. Let the mass of the block be 2 kg. Mu s value, let it be 0.5. So limiting friction, how much we'll get? Fl equal to mu s n. So mu s value 0.52 into 10. This will be 10 Newton. So I applied a force of say 2 Newton. I given a velocity of say 6 meter per second. Anybody, what direction the friction should act? Velocity is there and also applied force. The friction, the applied force is less than limiting friction. Look at the applied force. What is the limiting friction? I calculated here. How much we got it? 10 Newton. So look at the applied force. Applied force less than limiting. So friction acting should be static or kinetic. Static according to the definition. But we have given velocity. So what is the velocity of the block with respect to ground? Towards right. So therefore, who will determine the direction of friction here? So is there any relative motion between surfaces, whether you apply force or not? Is there any relative motion between surfaces? There's a relative motion, no? So therefore, in what direction the friction will act here like this, and it'll be kinetic. So mu k value, I'll give it 0.2. So what is the kinetic friction value? Mu k n or mu k mg. 0.22 into 10, 4 Newton. What is the state of block? What type of motion? The resultant acceleration will be like this, no? So the resultant acceleration will be in this direction. So what is the state of block? It will undergo retardation and somewhere it will come to rest. When it comes to rest, what will happen? The force acting will be continuous. I'll give a diagram. What actually happens? Somewhere in between. The velocity of the block will be v. It will undergo retardation. Still the applied force is acting continuously. And there's a kinetic friction. So therefore the block will undergo retardation. And finally what happen? Let it come to somewhere rest. Now here what conditions will arise? The moment it comes to rest, the applied force will be acting continuously. How much it is? 2 Newton. Then the moment it comes to rest, the applied force will try to shift it. But what is the applied force? Less than limiting friction. So therefore the friction will change direction. And here now what happened? I should not show a K, I should show it as static friction. This is final position. This is at t equal to 0. Got the idea now? But sir, why you are not showing kinetic here? Because here you are showing kinetic. Why you change the direction? The block will undergo retardation. Finally, the moment it comes to rest, the applied force is continuously acting. So the applied force will try to move. But what is the applied force? Less than limiting friction. So therefore the friction will adjust itself to kinetic friction. See, now look at the direction now. The direction of friction and the nature of friction changes here. It all depends on situation. You should be very alert. So I'll put a condition. What is the F? The applied force. F equal to 2 Newton. Continuously acts on the block. Okay, these are some the very basic things. Yes, there's a why kinetic friction. There's a relative motion. Why a static friction? Because there's no motion. So what is the state of the block? It'll come to rest. Final position. What when finally the block comes to rest here. Finally,